Hi guys, this is O-level chemistry, paper 11, November 2019, question 11. The diagram shows an electrolysis experiment using inert electrodes. Okay, so we have aqueous copper sulfate in setup L, and we've got dilute sulfuric acid as the electrolyte in setup M. Okay, which row shows what happens to the concentration of the electrolyte in L and in M as the electrolysis proceeds? So a tick mark says concentration stays constant, and an X represent concentration does not stay constant. So when the electrolyte is used up, so concentration does not remain constant for sure. In L, we would have copper depositing, copper ions depositing as copper metal. So the concentration would be decreasing. And in M, we would have water being electrolyzed. So dilute sulfuric acid would become more concentrated. We would have concentration increasing. So for aqueous copper sulfate, the concentration decreases. For dilute sulfuric acid, the concentration increases. In both cases, the concentration does not remain the same. So this makes option D the correct option for this question. Question 12. Molten sodium chloride is electrolyzed. Which equation correctly shows the reaction that occurs at the cathode? Cathode is where reduction takes place. So at the cathode, we would have Na positive accepting an electron forming Na. And at the anode, we would have 2 moles of chloride ions producing Cl2 gas and releasing 2 electrons. So the correct option here would be C, because sodium is gaining that electron and is being reduced, making option C the correct option for this question. Question 13. An energy profile diagram is shown. What does the arrow R on the diagram represent? So this is the difference between the energies of the reactants and energies of the product. That means this represents the enthalpy change that takes place during the reaction, and this is an exothermic reaction. So an endothermic energy change? No. Endothermic would point the arrow upwards. The products would be at a higher energy than the reactants. So this is incorrect. B, the activation energy? No, the activation energy is represented by a line from the reactants till the maximum energy state known as the transition state. This is activation energy, not R. The energy taken in by the reactants. Taken in means it would be endothermic. This is the energy given off by the reaction. So D says the enthalpy change of the reaction. Yes, this is delta H, making option D the correct option for this question. Question 14. Which statement about exothermic and endothermic reactions is correct? In an endothermic reaction, energy is used to break bonds, but no energy is released when bonds are formed. No, 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 no. In all reactions, energy is taken in to break the bonds and energy is released to form bonds. But the difference in the energies is what makes the reaction endothermic or exothermic. If more energy is given off than taken in, then the reaction is exothermic. If more energy is taken in than given off, then the reaction is endothermic. Next, in an endothermic reaction, energy is released when bonds form, but more energy is used to break bond, is needed to break bonds. Yes, yes, this is correct. Next, in an exothermic reaction, energy is released both by breaking and forming bonds. No, the difference in energy is the energy released. And next, in an exothermic reaction, energy is released when bonds form, but no energy is needed to break bonds. Of course, energy is needed to break bonds. Bonds cannot break without energy. This makes option B the correct option for this question. Question 15. Gas P decomposes to form gas Q. X moles of P produces Y moles of Q. Okay. Two experiments are carried out to investigate the rate of reaction. The conditions are the same except the two different temperatures, T1 and T2 are used. The results are plotted on the graph, drawn to the same scale. Okay. Which row is correct? So X is 2, Y is 3, molar ratios. Okay, initial X and final Y. So initially we have X here. So this would be 1, 2, 3, 4, 5, 6. This would be 6. X would be 6. And this is the final Y produced. So 6, 7, 8, 9. And Y would be 9. Now 6 is to 9 is the same as 2 is to 3. So X would be 2, Y would be 3. So X2, Y3, X2, Y3. Options C and D have been eliminated. Options A or B might be correct. Now, the temperature T1 is higher than T2. In order to test this, we need to see how quickly the products are forming. So when we look at the point where the product and the reactant volumes are the same, in T1, we have it here on the scale, and in T2, we have it here. So it takes longer to form equal volumes of the two reactions and products compared to T1. So it is sooner for T1. So if T1 has the volumes changing sooner, that means T1 is a higher temperature. So in option A, T1 is higher than T2 is correct. In option B, T2 is higher than T1 is wrong, making option A the correct option for this question. Question 16. In which reaction is the underlined substance reduced? So in A, carbon has an oxidation state of 0. It is going to CO, in which the oxidation state is +2. This is oxidation, not reduction. In B, we've got chlorine with an oxidation state of 0, going to chloride ion with an oxidation state of -1. 0 to -1 is reduction. In C, we've got magnesium with a charge of 0, forming MgO with a charge of +2. This is oxidation. And in D, we've got zinc with a charge of 0, forming Zn2 plus ion with a charge of +2, making it oxidation. So the correct answer for this question is option B. Question 17. The equation for an industrial process is shown. Carbon plus steam gives carbon monoxide and hydrogen gas. And this is an endothermic reaction. Which row is correct? The oxidizing agent is. The oxidizing agent undergoes reduction. So carbon has a charge of 0. It is oxidized to +2. So itself is oxidized. So it is a reducing agent. Reducing agent is carbon. So the oxidizing agent would be H2O, because in H2O, hydrogen has a charge of +1. In hydrogen gas, it has a charge of 0. +1 to 0 is reduction. When it is reduced, it will oxidize the other species. So the oxidizing agent is water. Options A and B have been eliminated. The reducing agent is carbon, which is there in both the options. And this reaction has a positive sign, so it is endothermic, making option C the correct option for this question. Question 18. Sodium hydroxide is added to a solution to alter its pH. A neutral solution is formed. Which statement is correct? Sodium hydroxide is an acid and reacts with an alkali to form water as a product. No, it is a base. Sodium hydroxide will lower the pH of the solution. No, it will increase the pH of the solution because it is a base. The pH of the neutral solution is 14. The pH of the neutral solution is 7. The pH of the solution before sodium hydroxide is added is below 7. Yes, because it is reacting with an acid. Acids have a pH of less than 7. So this makes option D the correct option for this question. Question 19. Sodium chloride is dissolved in distilled water. Universal indicator is added to the solution. What is the color of the universal indicator? Okay, so for universal indicator, we need to remember three different colors: the most acidic, the neutral, and the most basic. Under neutral conditions, universal indicator appears green. Under extreme acidic conditions, it has a color of red, and in the basic condition, it has a color of blue or purple. It is between blue and purple. So this needs to be remembered. Now, what is the color of the universal indicator? Now we have sodium chloride dissolved in water. That makes it neutral. So neutral, we have the color green, making option B the correct option for this question. Question 20. Which statement about ammonia is correct? It is colorless, yes. Odorless gas, no. Ammonia has a pungent smell. It is a gas that turns damp blue litmus red, no. It turns damp red litmus blue. It is formed when potassium nitrate is heated with aqueous sodium hydroxide and aluminum. Yes, this is a test for nitrate ions. When you have nitrate ion present, you add aqueous ammonia. No, sorry, not aqueous NaOH, and you add aluminum foil and heat. This produces ammonia gas, which turns red litmus blue. So, yes, this process will produce ammonia. It is manufactured using vanadium 5 oxide as a catalyst? No. Haber's process involves the use of iron or Fe2O3, iron 3 oxide as a catalyst. V2O5 or vanadium 5 oxide is used in the contact process. So this makes option C the correct option for this question.